Hello everyone, this is Dr. Zach. Today in AP Calculus, we are going to be drawing slope fields. Let's get started. So a slope field is a graphic that describes the slope at each point for a given derivative. So for example, our derivative dy dx is -1 over x squared. If we were to look at x equals 1, the slope at x equals 1 is going to be -1 over 1. So take a look. All of the slopes that we see are going down 1, right 1. If you were to extend all of these little slopes along the vertical line, x equals 1. Now, if we were to look at x equals 3, you would notice that your slope dy dx is going to be equal to -1 over 9. So take a look at 3. The slope is -1 and over 9, down 1 over 9, down 1 over 9. Now these are just short line segments to describe what's happening at the slope at each of these x values. Our goal is to draw the solution through the slope field. We are told that our x's are all greater than 0 and that we're passing through the point 1, 3. So you want to mimic what's happening at these values. So I'm going to draw down 1 over 1, and then notice it's kind of pointing towards my next field, and the slope is becoming less steep as it crosses through those vertical lines. So you are going to generate the graph of what your slope might, or what your function might be doing given the slope field. And on the left side of my graph, it looks like my graph should be heading upward. So a slope field gives you an idea of what the function should look like when it passes through the one point, and then you're extrapolating those ideas to continue the function. For example 2, we're drawing the slope field through our 16 given points. And we're then going to draw the particular solution. So particular solution means the one graph or function that travels through 0, 3. We begin with our derivative. dy dx is -2x minus 1. We might want to organize our data, choose some x values, and then determine the derivative through those x values. So I'm going to start at x equals -2. When I put -2 in, my slope is going to be -2 times -2 minus 1, or 3. So I'm looking at my first dot. I need to draw a slope of 3. So that means it has to head up 3 and over 1. So I want to point my slope towards the 1 that I've marked. Now, since x is -2, all of these slopes are parallel. So draw them as best you can, parallel to one another. Now let's figure out x is -1. When you substitute -1 in, you get a slope of 1. So when you draw your slope of 1, make certain that you've changed the angle so that it goes up 1 over 1, up 1 over 1. And for x equals -1, draw in all your slopes again. For x is 0, our answer is -1. So the slope is changing. It's going down 1, right 1, down 1, right 1. Draw in all of your slopes. And now x is 1. When we substitute our 1 in, we end up with -3 as our slope. So we want a downward slope of -3, so that's down 3, right 1, and draw those a little bit more steep than the ones we drew earlier. So next, we want to start at 0, 3. Place your dot. We want to follow the graph. What is our graph doing at 0, 3? You can see it's heading downward. So we're going to follow the graph downward. On the left side, we went from a negative slope to a positive slope. So we want to make certain that somewhere along the way, our slope was 0, somewhere in between those points occurred. And there we have a representation of our particular solution through 0, 3. If you draw multiple particular solutions through different points, you can see that all your particular solutions should be parallel. The reason for this, if you have some sort of function, f of x, and you added a value, let's say 1, Or if you had f of x and you subtracted a number, let's say 1, negative 1, or even just f of x. If you were to find the derivative of all three of these functions, their answers would be f prime of x, even though the original problems were different. Now, for example, for number 1, I'm giving you the slope dy dx is negative x over y. So you can have a function that mixes the x and y values. We want to draw the particular solution through 1, negative 1. Always check that you have the correct units when you're graphing. So 1, negative 1 seems to be pointing upward, but then as you can see, there's some sort of change going on and it curves back around. And when it's curving back around, you then want to follow your other fields. So it looks to me like this problem could actually be a little bit circular. For your next slope field, you're given 16 points again. Draw your table of values. You want to have x and y this time, and figure out negative x plus y. So I want you to plot all of the values for this slope field given each one of the points. So for example, the first point you might attempt to do would be negative 1, 0, and your answer would be 1. So when you plot the slope for negative 1, 0, you probably want to have it look like that. You have 16 points to fill in, and then you'll be all set to attempt the homework. That's it for today's lesson. Remember, slope fields are just a graphical representation of your derivatives.